Hi everyone, we're starting our last section in Chapter 9, which is on problem solving with quadratics, and it's found in section 9D of your textbook. So when we need to problem solve now word problems, what we are looking at is we're looking at using all the forms of factorization that we've learned thus far, and we're now applying them into word problems. And how do we solve word problems using factorization? Now, before we get into all of that, we just need to go over some basic rules. Some of those basic rules are that once you have read the question, you are to A, look at the information, rewrite it in algebraic terms, but we need to remember first of all that you need to represent what your unknown is. So you must always make your initial statement as x, let x equal represent this, or let x equal represent that, and so forth. That absolutely needs to be stated right at the beginning. You then translate that that variable into an equation, into an appropriate equation, and then we solve that equation. Once we have solved the equation, then we must look at it and take a look to see whether it is a reasonable solution. Is the answer that you have gotten, is it reasonable? Does it make sense? And then the very last thing that you'll be doing is you'll be placing your answer in a statement. So you must always write a final statement saying what your length is, or what your width is, or whatever the question is. You will be saying, therefore, the width of the fence is such and such, or depending on what the question is. All right, so let's take a look at the first question. The first question has a farmer that wants to enclose a garden, and he's got 100 meters of fencing. Now, what they want you to do at first, in part A, is they want you to write if the garden is x meters wide. So I have already written up here that x is my width. And if x is my width, that means that my value of the length is going to have to be 100 minus 2x. Now, why is it 100 minus 2x? Because our perimeter is equal to 2 times the length plus 2 times the width. And if our value of the width is equal to x, then it's 2w. And now, because the perimeter is equal to 100, then it's going to be equal to 100 minus 2w, which is equal to, it's 100 is equal to 2 times the length plus 2 times the width. Okay? And now, since I can leave it like this for the moment, and since the question is asking us to find the length first in terms of x, then I can start by saying, well, in terms of length, I will have 100 is equal to 2L plus 2W. And because W is now being replaced with the value of x, so let x equal the width, okay? Then I can write 100 is equal to 2 times the length plus 2x. Now I bring because I want to isolate for the length, because I'm looking for L at this point, I will end up having 100 minus 2x is equal to 2 times the length, which tells me that the length is going to be equal to, if I now divide everything by 2, it'll be equal to 50 minus x. So that would be my length right there. Now, if I want to look for my area now, well, my area is really equal to length times width. And since the length is now equal to 50 minus x, and I know that my width is equal to x, I get area is equal to x times 50 minus x. And from there, I discover that my area then is equal to 50x minus x squared. Now, in solving part B, they want us to find the width of the garden that has an area of 525 meters squared. Since I have already determined that the area, or the formula for the area, is 50x minus x squared, then I can say that the area in part B, area, is going to equal 50x minus x squared. The area I know to be 525 That's equal to 50x minus x squared. Oops. Now I can bring everything over to one side because I've got a quadratic trinomial. I'm going to set it equal to 0 because I want to solve for x, the width. And therefore I will say x squared minus 50x plus 525 is equal to 0. And now I'm going to search. I can use different methods here to figure out what the value of x is. So I could try to use sum and product. I could use the quadratic formula if I wanted to. I could even complete the square, but I don't really suggest completing the square at this point. It would just be too long and convoluted. The numbers are too big, and you just risk making more errors. So in looking at the problem, I could use the quadratic, and it might be the better way to go using the quadratic if you can't think of the two values or the two terms that multiplied together give me 525 and added together give me 50. But the numbers actually do turn out to be 35 and 15, so that I can actually break this up into x minus 35 times x minus 15 is equal to 0, so that either x is equal to 35 or x is equal to 15. Now this is telling me that the possible values for my width of this rectangle, okay, could be 2. I could either have, therefore, the width could be either 35 meters or it could be 15 meters. So the width could be either or. It could be either 35 meters or 15 meters. And there is my final statement with the therefore. All right. So I had everything here that was required. I had my opening statement here where I've check marked. I have my my opening statement where I said let x equal to something. X was equal to the width. I found my value of the length in terms of x. I found my area, my formula for the area, and then I solved for what the possible values of x are, or the values of the width, and I made my final statement. All right, let's take a look at another example. It says, is it possible to bend a 12 centimeter length of wire to form the legs of a right-angled triangle that has an area of 20 centimeters squared? All right, so if I quickly draw out my triangle, okay, there's my right-angled triangle, I can say let one side equal x. So I say let x equal one leg, okay, and therefore I can then say that 12 minus x has to equal the other leg. Okay, so the legs are these are the two legs, because the other side there on the 90-degree triangle is the hypotenuse. Now, I have an area of 20 centimeters squared, so I know area is equal to 1/2 base times height, or base times height divided by 2, and I know that the area is equal to 20, and I know that I've called the base x, and I've called the height 12 minus x, and it's all divided by 2, so that I ended up getting 40 is equal to 12x plus x squared. Now, I'm going to bring everything over to one side of the equation. I get x squared plus 12x minus 40. And I try to see if there are two numbers that multiplied together give me negative 40, but added give me 12. Nothing seems to come to the top of my mind right now in terms of what those factors could be. So I'm going to go for the quadratic at this point. Might as well. So, and I could use, if I'm not using the quadratic, I could be using the completing the square. So I'm going to use the quadratic right now because I'm too lazy to do the other method. So I use the quadratic where I say negative b plus or minus b squared minus 4ac all divided by 2a, and that would be my value of the x. I'm looking for, again, remember, I'm looking for the length of the wires, the length of the legs of the wire. So that I will have negative 12 plus or minus, and it'll be 12 squared minus 4 times 1 times negative 40, and that all gets divided by 2 times 1. Alright, so I've caught an error that I made here. The error being that x times 12 is 12x, but x times x, negative x, gives me negative x squared. So this should be a negative x squared. And in having that, that changes my entire expression here, so that I'm going to bring everything over to the left-hand side of the equation. So it's x squared minus 12x plus 40 is equal to 0. As a result, my quadratic is going to change, so that I end up getting negative 12 plus or minus, and it'll be negative 12 squared minus 4 times 1 times 40, and that all will be divided by 2 times 1. And when I go to solve for x here, I discover that I've got 12 plus or minus the square root of 144 minus 160, all divided by 2. I can actually really stop my problem right here, because I'm going to get a negative answer under that square root sign. So that 160 take away 144 will give me 16. So it's negative 16, all divided by 2. I cannot have a negative under the square root, and therefore my answer to this problem is going to have to be simply, it is not possible. There is no solution. There's no solution, and thus it is not possible to bend the wire. To form the legs of the triangle. Okay? So that's basically your solution there. Alright, let's take a look at another example. And the example says that you have a rectangle that has length 3 centimeters longer than its width, and its area is 42 centimeters squared. Find its width. That's a relatively easy question, in that all I need to do in this question is definitely I will make my rectangle. I will say let x equal the width. Therefore, that means that x plus 3 has to equal the length. If we know the area is 42, then area is equal to length times width. 42 will equal x times x plus 3. 42 will equal x squared plus 3x, and I will say that 0 is equal to x squared plus 3x minus 42. I need to find two numbers that multiplied together equal negative 42, but summed up together will give me positive 3. So 0 is equal to, that will equal to, so as I was saying, it will equal to negative 42 multiplied and added will give me positive 3. I can't think of any two numbers again off the top of my head, so that I will use the quadratic in this case as well. So again, I will use the quadratic, and in using the quadratic, I will say my value of A is equal to 1, my value of B equals 3, my value of C equals negative 42, so that it's negative 3 plus or minus with the quadratic, and it'll be 3 squared minus 4 times 1 times negative 42, and that's all going to be divided by 2 times 1. This will be my value of x, so that I will have negative 3 plus or minus 9 plus 168, all divided by 2, which will give me negative 3 plus or minus the square root of 177, all divided by 2. That's my answer. Now I can obviously figure out what the answer is with decimals. Okay, so I would end up getting negative 3 minus, so x would equal negative 3 minus the root of 177 over 2. And that'll give me a negative number, because negative 3 minus, let's say, 10 point something, 11 point something, okay, actually more than that, it's like 13. So that it's approximately 13 point something. That'll give me a negative number. So that's a negative number, and definitely I can't have a negative as a length of a side, so that will be excluded as a possibility. But if I do x is equal to negative 3 plus the root of 177, all divided by 2, that'll give me negative 3 plus, again, it's approximately 13 point something. I don't have a calculator with me right now, but I guess I could just open it up very quickly. Let's see. I can open it up very quickly. Let's try it again. So I can open up the calculator very quickly, and I can just take the square root of 177, enter, it's 13.3, so it's 13.3, and I would subtract 3 from that. That would give me 10.3, and then, so it's 13.3, and then that would be divided by 2. So that would be then divided by 2, so it's approximately going to be 5 point something. So I get 5.15, more or less. That would be centimeters. So the first example would definitely not work with the negatives because I can't have negative answers. The second one will give me an answer of approximately 5.15. If you wish to leave your answer, though, in terms of the radicals, I suppose that would be more than acceptable as well. All right, let's take a look at the next example. The next example is asking you to find the value of x, and I'm looking at part B here. And in part B, what I'm looking at is proportions. So I'm looking at proportions here. And in the proportions, I can say, well, I need to find the value of x, so of the small triangle, compared to the bigger triangle. So I could really do my proportions and say, well, x compared to the entire length of x plus 5 is going to have to be the same as the value of the length of the 4 over the entire length, which is x plus 3. Now, in doing that, okay, we are going to have to cross multiply here so that I have x bracket x plus 3 is equal to 4 times x plus 5, so that I get x squared plus 3x equals 4x plus 20. I'll bring all my x's over to one side of the equation. I'll bring everything over to one side of the equation and set it equal to 0, so that I have x squared minus x minus 20 is equal to 0. And now I can definitely take a look at this and use sum and product, where I have x minus 5 and x plus 4 is equal to 0. So either x minus 5 equals 0 or x plus 4 equals 0. So x is either equal to 5 or x is equal to negative 4. So because I can't have a negative length, then I can exclude the x equaling negative 4, and therefore the length of side x is 5 centimeters. Now, note that I forgot to write down what the value of x was. Let x represent the length of the side. And I'm going to go so far as to say of the small triangle. Okay, done. That's done. Let's take a look at one more example. And the last example says that we've got a sum. The sum of a number and its reciprocal is 5.5. So the sum of the number and its reciprocal is 5.5. Find the number. So I can say, well, let x equal the number. So that means that 1 over x has to equal the reciprocal, because it's the opposite. Now, if it's the sum of those two numbers, then it's x plus 1 over x has to equal 5 and 1/5. I'm going to change 5 and 1/5 to 26 over 5. So, doing that, I'm going to get a common denominator of 5x throughout the entire equation here, so I can get rid of these denominators. So I'm going to multiply top and bottom of the first term here by 5x, so it goes to 5x squared over 5x, plus I'm going to multiply this by 5 over 5x, and then that will equal 26x over 5x. My 5x's cancel out in the bottom, so that I end up getting 5x squared minus 26x plus 5 is equal to 0. Now, I'm going to choose to do splitting the middle term here. It might work. So I'm going to see what two numbers multiplied together, a times c, is going to equal 25. But the sum of those two numbers, so the sum of the b term, this is the multiplication, the sum of the two terms has to equal negative 26. I think the numbers are going to be negative 25 and negative 1. So I can start writing out 5x squared minus 25x minus 1x, or just minus x, and then plus 5 is equal to 0. I have four terms. I can group them into groups of 2 and 2. So I remove a 5x, and I'm left with an x minus 5 minus 1 bracket x minus 5. I have identical binomials here, so I know I've done this problem correctly. I can remove my common factor of x minus 5, and what's left over is a 5x minus 1 equaling 0, so that either x minus 5 equals 0, or 5x minus 1 equals 0, and x is either equal to 5, or x is equal to 1/5. This question probably didn't even require all of this work, because the numbers actually turned out to be just 5 and 1/5. So that was probably not even required. Therefore, we can say the numbers are, following our schema here, therefore, in writing our final statement, therefore the numbers are 5 and 1/5. Done. All right. Your classwork or your homework that I would get started on is on exercise 9D, questions 1 through to 13, 17, 21, and 23 to 25. See you next time.